Hey Ted, it's Nathan, and I'm doing your coding challenge for the week. This was the chess nights, and I don't actually do any sort of JavaScript or HTML development, so I'm just going to do the algorithm in the background and talk through the thought process. So the coding challenge prompt was to be able to place a knight on a chessboard and some sort of target somewhere on the chessboard, and then highlight the shortest route between the knight and that target. So the way that I went about thinking about this first was to make a map like this of a chessboard and arbitrarily place a knight somewhere in the middle, and then try and find some sort of pattern when it comes to where can this knight go in a certain number of steps without backtracking. So if you start the knight here, all of these these blue ones are where the knight can go. So then if you look from there, all of these blue knights can go to all of the red twos. And so far and so forth, going until the fours. And yeah, there's a pattern, but I wanted to see, is there just like some sort of algorithmic way you could do this really simply and not have to essentially brute force it? And so to kind of test this out, this pattern, I looked at putting the knight in the top left and putting the target down here in the bottom right and seeing what problems might show up. So did the same thing, colored through all of the steps. And the problem that you run into here, just trying to say, all right, well, if I want to start here, I can get here in X number of moves. That's good information, but you run into two problems. And the first one is that if you just look at starting here and ending up here, one of the things that you can do is you can know, all right, well, I can get 1 here, and then I can go 2 here, 3 here, 4 up here, and then 5 here. And even though there's a 5 here, there's no way to get down here to this 6. So there's nothing special necessarily about knowing how many moves it takes to get somewhere, with one exception, which is once you're there, if it's the first time you visited it, then it's the shortest path by definition. The other issue is that, see here, we've got threes and a kind of plus sign and then twos surrounding them. But here, the knight has threes next to it, and it's got the twos, but then this is a 4. And it's a 4 because there's no easy way, like you can't go up here to get back down here. In 2 steps, so you can't go 1 and then 2, so you've got to go around. So that tells me that there's probably not that I could figure out, any sort of way that you can just use some loops and figure out, using a map of some sort, how many moves it takes and how to get there in the shortest way. So what I ended up doing is doing this in Python, and let me just walk through, that's probably really small, walk through some code here. So what we're doing first is we are setting up the board, and this board is just a list of lists. It represents different cells in the board, and there's a none in each of them. I want to make sure that the board, which is 0 to 7, you put in where is the knight located. I'm saying the knight's located at 0, 0, and the target is 7, 7 to start with, which is this example here. So we want to choose one of those numbers, and then we want to set where the knight is located on the board itself, and then say what we're currently looking at is just the knight to begin with. So it would be a whole bunch of nones and then 0, 0 up here. And then iteratively, what we want to do is say, whatever we're currently looking at, let's look at all of these things and see where can we go from this current cell. So there's an algorithm that essentially what it does is it looks at wherever you're currently at and says, where can I go? In which case, in this one, you would say, well, I can go right 2 and down 1 to this one, and I can go down 2 and right 1 to this one. And I could, in theory, go up 2 and right 1, but that doesn't exist on the board. So there's logic to say, where are all the places that I can go, and then are those places valid or not? And then what it does is it fills in that information in that cell. It fills in what's the shortest route to get to that location. And so all it does is it takes the cell that you're coming from. So in this case, it would just be a cell with a list that says 00 in it. And then you would say, for this cell here, you would say, this cell is now 00, comma, 12. And just so far, so on and so forth, down to here. So once we finally get to the condition where your target is somewhere on the board, so your target will show up if it's valid. If your start and end points are valid and you don't go out of bounds, you'll always find that place to go, and so you can. You can always get there. And when you get there, this map kind of shows us that the shortest distance between here and here is 4 moves. Here is 6 moves. So no matter what you're going to do is find the 6 move option. Maybe there's multiple ways to get there, but whatever you get is going to be the shortest one. So at the end, it prints out the board and then finally returns just that final path to get there. So we'll look at the example from 00 to 77 here. We've got a bunch of debug text. And then our final path ends up being 00, 1, 2, 3, 3, 4, 5, 3, 7, yada, yada, yada. So we just paste it up here, and we can see that it goes 00 to 1, 2 to 3, 3, and then we go to 4, 5, and then 3, 7, which is here, and then up here, and then to 6. And those are our 6, well, there's 7 points, but 6 moves to get here, and that's the path. So I guess what I would do if I were going to make this visual is allow the person to place a knight and then place a target, and then use those cell locations that the user selects as the input to this function. Then the output of this function is these cells, and then I would have it, once it runs, it would just return this list, and then use this list to create paths from the start to the end, and that would be it. So thanks for listening to my 8 minutes of rambling about the Knights of Tedonia.